So good morning students. So today we are going to see about the properties of Z transform. So the first property is linearity property. So what does mean by linearity? So linearity means it obeys the principle of superposition principle. So let the weighted sum of inputs which is equal to weighted sum of outputs is nothing but linearity, and let x of 1 which is equal to x1 of z and x2 of n which is equal to x2 of z be two transform pairs with ROCs r x1 and r x2 respectively. We have a into x1 of n plus b into x2 of n lies between a into x1 of z into b into x2 of z. So it ROC is denoted by r, which includes r x1 intersection r x2, where intersection is the operator. So that is r contain at least the intersection of r x1 and r x2. So for example, determine the Z transform of y of n is expressed as y of n which is equal to x1 of n plus x2 of n means, so where x1 of n which is equal to 0.2 power n into u of n and x of n which is equal to minus 0.3 power n into u of n. So u of n is a unit step function. So units of this are already specified in the elementary function. And from the table, the transform of x1 of n and x2 of r is x1 of z and x2 of z which is equal to x1 of n which is equal to 0.2 power n into a 0.2 power n into u of n, that is a power n into u of n which is equal to 1 divided by 1 minus 0.2 into z power minus 1, where modulus of z greater than 0.2. So and x2 of n which is equal to minus 0.3 power n into u of n means 1 divided by 1 plus 0.3 into z power minus 1, where modulus of z greater than 3. According to the linearity property, the z transform of y of n is equal to, so y of z is equal to 1 divided by 1 minus 0.2 into z power minus 1 plus 1 divided by 1 plus 0.3 into z power minus 1. So where modulus of z greater than 0.3. And the next property is time shifting property. That time shift of n naught is x of n causes a multiplication of z power minus n naught and x of z. So where x of n minus n naught lies between x of minus n naught into x of z. The ROC for x of n minus n naught is basically identical to that x of z for the possible additions or deletion of x which is equal to 0 or x which is equal to infinity. Say for example, find the z transform of x of n which has the form of x of n which is equal to a power n minus 1 into u of n minus 1. So employing this time shifting property with n naught which is equal to 1 means a power n into u of n lies between 1 divided by 1 minus a into z power minus 1 modulus of z greater than modulus of a. We easily obtained a power n minus 1 into u of n minus 1 plus minus z power minus 1 into 1 divided by 1 minus a into z power minus 1 which is equal to z power minus 1 divided by 1 minus a into z power minus 1. So where modulus of z greater than modulus of a. So that using which modulus of a greater than a also produces the same result. So but the approach is less efficient. So that is x of z which is equal to summation n which is equal to 1 to infinity a into n power 1 into z power minus n which is equal to a power minus 1 summation n which is equal to 1 to infinity a into z power minus 1 the whole power n which is equal to a power minus 1 into a into z power minus 1 minus a into z power minus 1 the whole power infinity divided by 1 minus a into z power minus 1. So which is equal to z power minus 1 divided by 1 minus a into z power minus 1. Then multiplication of exponential sequence. So modulation, if we multiply x of n by x0 of n is the time domain, so the variable x will be changed to x divided by x naught in the transform domain, that is x naught n of x of n lies between x of z divided by z naught. If the ROC for x of n is r plus less than modulus of z less than r, the ROC for z naught of n x of n is x of z naught r plus, where modulus of z greater than modulus of z naught r plus and less than z naught r minus. And example of the following is a transform pair and u of n lies between 1 divided by 1 minus z power minus 1. So where modulus of z greater than 1. So find the z transform of x of n which has the form of x of n which is equal to a power n into cos of bn into u of n. So nothing that cos bn which is equal to e power j bn plus e power minus j bn divided by 2. So x of n can be written as, so the x of n which is equal to 1 divided by 2 into a into e power j beta the whole power n into u of n plus 1 by 2 into a into e power minus j beta the whole power n into u of n. By means of modulation property, so with the substitution of z naught which is equal to a into e power j beta and z naught which is equal to a into e power minus j beta, we obtained 1 divided by 2 into a into e power minus j beta n into u of n lies between 1 divided by 2 into 1 minus z divided by a into e power minus j beta the whole power minus 1 and 1 divided by 2 into 1 minus a into e power minus j beta into z power minus 1. So where modulus of z greater than modulus of a and 1 by 2 into a into e power minus j beta the whole power n into u of n lies between 1 divided by 2 into 1 divided by 1 minus z divided by a into e power minus j beta minus 1 which is equal to 1 divided by 2 and 1 divided by 1 minus a into e power minus j beta into z power minus 1 where modulus of z greater than modulus of a. So by means of the linearity property is follows that x of z which is equal to 1 divided by 2 into 1 minus 1 by 2 into 1 divided by 1 minus a into e power j beta into z power minus 1 plus 1 divided by 1 divided by 1 minus a into e power minus j beta into z power minus 1 which is equal to 1 minus 1 minus a into cos beta into z power minus 1 divided by 1 minus 2a into cos of b into z power minus 1 plus a2 into z power minus 2 and modulus of z greater than modulus of a. And fourth property is differentiation property. So differentiating x of z with respect to x corresponds to multiply x of n by n in the time domain. N into x of n lies between minus z into d by dz of x of z. The ROC for x n into x of n is basically identical to that of x of z except for the possible addition or deduction of z which is equal to 0 or z which is equal to infinity. Say for example, determine the z transform of x of n which is equal to n into a power n into u of n. Since a power n into u of n lies between 1 divided by 1 minus a into z power minus 1. So where modulus of z greater than modulus of a and d by dz of 1 divided by 1 minus a into z power minus 1 which is equal to d into 1 minus a into z power minus 1 of minus 1 divided by d of 1 minus a into z power minus 1 into d of 1 minus a into z power minus 1 divided by dz which is equal to a into z power minus 2 divided by 1 minus a into z power minus 1 the whole square. By means of the differentiation property we have n into a power n into u of n lies between minus z into a into z power minus 1 divided by 1 minus a into z power minus 1 the whole squared which is equal to a into z power minus 1 divided by 1 minus a into z power minus 1 the whole squared. So where modulus of z greater than modulus of a. And conjugation property, the z transform pair of x of n is x complication n complement of x lies between x complex conjugate of x z and complex conjugate of z. So the ROC of x complex conjugate of n is identical so that of x of n. And the next is time reversal property. The z transform pair of x of minus n is minus n lies between x of z power minus 1. If the ROC pair x of n is r plus modulus of z less than r plus and less than, greater than r plus and less than r minus the ROC of x of minus n is 1 by r into modulus of z less than 1 by r plus. Modulus of z greater than 1 by r minus and less than 1 by r plus. And determine the z transform of x of n minus x of n which is equal to minus n into a power minus n into u of minus n. So using examples, n into a power n into u of n lies between, so a into z power minus 1 divided by 1 minus a into z power minus 1 the whole square. So the modulus of z which is equal to modulus of a, and from the time reversal property x of z which is equal to a power z divided by 1 minus a z the whole square which is equal to a inverse into z power minus 1 divided by 1 minus a inverse a power minus 1 into z power minus 1 the whole square. So where modulus of z less than modulus of a inverse. So the next property is convolution property. So let x1 of n which is equal to x1 of z and x2 of n x2 of z to be the z transform pairs with ROC and R1 and R2, Rx1 and Rx2 respectively. Then we have x1 of n convolution, x2 of n lies between x1 of z into x2 of z, and its ROC indicates R1 x1 of n intersection or x2. The proof is given as follows. Let so y of n which is equal to x1 of n convolution x2 of n which is equal to summation k which is equal to minus infinity to plus infinity x1 of k into x2 of n minus k. So with the use of this time shifting property, y of z is which is equal to summation n which is equal to minus infinity to plus infinity summation k which is equal to minus infinity to plus infinity x1 of k into x2 of n minus k the x z power minus n which is equal to summation k which is equal to minus infinity to plus infinity x1 of k into summation n which is equal to minus into plus infinity x2 of n minus k into z power minus n. Summation k which is equal to minus into plus infinity x1 of k into x2 of z into z power minus k. So where z1 of z is equal to z2 of z is nothing but conjugation property. So that's all about the property of z transform, and next class we will discuss the next chapter. Thank you, students.